Okay, my friends, shocking as shocking can get. I now have every bit of evidence to prove every single word I've said about the dipole electron flood, which is this, and I've shown the pictures of them. Now, the center is dark matter. Wrapped around it is the particles that interact with other particles, and they share electrons and so forth in that layer. And there'll be a black hole in the center of this one too. That's the gravity holding that particle together. And then we must have an excess of dark matter in the Earth to give us a lot of gravity. That's why it holds everything together and pulls it down to Earth. That's the gravity. And then on the outside, where the gases are as far away because they're much lighter, they don't have as much weight to bring them down to gravity, they scrub outside around the universe through the particles that are in the universe. It's saturated. It's not just one area, they're everywhere. They know it's not a vacuum. Therefore, all of the things they're doing with Webb and distances and times and history, it's not correct. It's just not right. So I'm going to show you what I have been doing, working with a bunch of other people. I'm primarily just in the recent few weeks, Mason. And he's got a Newtonian telescope, and he's altered it and changed it and taken off all the filters so that there's nothing suppressed. They call it noise. Too much of this business going on over here. Take that noise out. No. Let it come through, because it's not homogeneous. If it was always the same thing, well, that would be different. But it's not it's not homogeneous. So anyway, we'll get into it. All right. I've never seen anything close to what he's doing. We use CMOS, and that's the reason you can see all this stuff. CMOS is complementary metal oxide silicate semiconductors. It's the oxides that create these energy levels. I'm trying to work oxygen into these energy levels, because those are the things with combustion. You need a lot of oxygen for high combustion. Oxygen, light is basically almost the same thing as combustion. We're going to talk about all that stuff. Now, look at that. That's his image. This is Mason. There's Saturn, and this is the stellarium star map. I'm going to show you this stuff so there'll be no confusion. And he's got a galaxy cluster here and a galaxy cluster here. That's not Mason's. Mason's over here. This is probably, I don't know who actually gets this data, but I'll show you where it exists on the internet. Now, so here's Saturn. For him, that's Saturn. That's pretty significant, but you see, it's got the same sort of effect. But then you got Titan over here. These fields are totally entangled. You don't see that. I don't see anything going on here. I see Saturn, sort of. And it has, the rings of Saturn are on the outside quite a ways away. That's what I'm seeing. Now, it appears that he knows what he's doing. I think he took this picture at the exact same time they were taking their picture, because you have to do it at the same time or it's going to be a different outcome. And I can see that he must have, because this, I would say, is this galaxy cluster, and this is that galaxy cluster. And these are those. And as well, let me show you. All right, this is so you can see where the stars are. And they move around like this, and the planets move through the soup. And this is what's called stellarium. And that's what I'm going to show you in a second. All right, what we're going to be looking at is Principal Galaxy Catalog, PGC. And they go by numbers and letters and all that business. There's been a lot of them. There's many, many, many. Now, you have to look at this. I don't want to pretend I know much about this, because I don't. I'm just starting to look into it, to be perfectly honest with you. And I don't think anybody else knows anything about it either, except for Mason. I really honestly don't. All right, this is that principal galaxy clusters, or catalog. PGCs. And they're all over the place here, and he was showing his. Now, what else can we see here? They're tracking Neptune. I don't know why. Object Neptune, open sky map. I'm sure it's the same people. I don't know. Who knows? I don't know anything about this. Just a fact. Now, Neptune is coming here, and this was 72 hours ago. And I guess the Neptune must be right about here somewhere now. And in the next 72 hours, in the next 144 hours. So you can actually watch that thing go. And it's going to obviously interact with everything else in the background. Now, I don't know if they have any idea how much field effect there is out there. It's just staggering. And every one of these galaxies, I don't know how far they are, but they're certainly not the distance they're talking about. They think light never slows down. It keeps going a bazillion miles an hour, never slows down. No, not correct at all. Light slows down, light speeds up. We've done them both. Now I'm going to show you something that Rod Warren and I did long ago. This phone came out in 2012. It was a Samsung Galaxy S3. And Rod bought one, and he's trying to do the double slit experiment. But instead of having a flat plate where the light spins through it a certain way, he made a Venturi. And the Venturi accelerated the light, and then when the light started to slow down, we could see the particles. So he gets a hold of me, or I forget how it all started, to be perfectly honest with you. I think he got a hold of me because I got a hold of him because I saw him putting these pictures up, and everybody was, what is that? Nobody had any idea. But when I saw it, I knew exactly what it was. So I went out and got the same stuff, and all he used was this exact same laser, construction laser. It's pulsed. It sends and picks up, so forth, and this phone. And a little tiny Venturi, very simple device. And we got these kind of results. Now, I'm not taking any credit for this at all. Rod did this, just on his own accord, looking for the double slit experiment. And he shined the light down through, and it was supposed to hit through the slits and create the pattern. Well, he could see the pattern. But not only could he see the pattern, it was accelerated because it was forced through a Venturi. So here's exactly what happened. He shot the light like this. The Venturi is here. All the Venturi does is it takes everything that's coming this way and it says, oh, you got to get through that little slot. And I said, well, I can't do that. I said, well, you're going to have to. And the black comes bash, bash, bash. And it's literally a subatomic nuclear explosion. It's in the nucleuses of the particles, which are the light particles, which are the photons. And we can see the photons. Here's the actual photons. Where I got some photons hanging around here. Well, here's some green ones. There's actual green photons. And it came through hot. Now it's slowing down. And you see the particle. And now this particle is charging up on the bottom. See down here, it's not charged up. It's charging up, and then it'll flip to the back. That's what they call the muon wobble. They see them going. They know this, it does this stuff. They can see some of this at the Large Hadron Collider. Nothing like we can see. We can see every little bit in detail. So that was the green. Same particle as the red. It's just not moving as fast. It's just like this here. The green is up here, same particle. And the red is down here. You see those waves? Those waves don't go that way. Those waves turn like this. They spin. Now, if you look at them this way, it looks like waves. But we look at them this way and we can see them spinning and throwing their particles off to the sides. And those particles are these particles, which are these particles, which are these particles, only these particles are moving way too fast to get the real good shot of them. These are way up in the high, almost into the gamma rays. They're way up here. See the blue? And I showed you before the green, and I showed you the red. And I can show you, well, I will. When this came in hot, it's drifting to the left. That means it's spinning to the right. And that's the right-hand rule. If it's going that way, it's spinning this way. Now, you can see there's two particles here. You can't see it here. It's just too fast. Light slows down, speeds up, all that. And it's a tubular spinning particle. And this is both of them at the same time, well, the green and the red, coming through the same Venturi, well, the same Venturis, basically, side by side. And the red is just getting pushed out of the way. It's just too powerful. The green is much more powerful than the red. Same particle. Just pushes it right out of the way. But you see the little red spots up here? It's really hard to understand some of this stuff. I've been working on this for years. And I think I've got a good handle on it. And this is the way the red comes in. Well, they all come in like this in a wave, because that's the wave. And I showed you the particle. The wave is a result of this particle pushing through all this resistance. All of that is resistance. Those fields are pushing back at these fields. And I think with a Mason, we're going to be able to see all that stuff happening. This is layered. I don't want to go through the whole thing 10,000 times, but I already have. He's taken layered shots, so we can see everything happening at once coming out. And it's all dipoles. All dipoles. That's Saturn right there. And I don't know what to think anymore. But he's the only, as far as I'm concerned, he's the only guy that's going to get us close to the solution here. And I have seen nothing, not a damn thing, other than Dylan. Dylan came up with this, and boy, I'll tell you, that rocked my world. But it did show the dipoles. I could see they were all dipoles. Well, look at this. And Mason's got one very, very crazy. I'm going to show you in a second. This looks like a damn pyramid, sending out scout ships back and forth to them. Something looks like Atlantis. What is this? Anytime you see white and black and white and black, it's some kind of a ripply effect. It doesn't look like a regular magnetic field. It looks like, but that doesn't look like, I just don't know anymore. All I can do is show you what's out there, what we can see. Look at this one. Again, this is Mason. This guy's got something going on. I'm going to tell you that right now. And we got a dark particle and we got a white area. Look at that. And that's one of the moons. I think it has like 250 moons. I was just looking at that today. Unbelievable number of moons around Saturn. And look at this. I think I showed you this. It's a dipole. There's Saturn. What is going on? I don't know. But I'm going to tell you what. You send light through that mess right there. It's not going to just keep going, never slow down. It's insanity to believe that. And I just showed you we can slow. Nobody can contest that. It slows down. Look at this one. That's Jupiter. The hell is going on here? We got dipoles. Something's, and now I know he knows what he's doing, and he can alter the length of how far in between. I don't know. I don't want to put words in his mouth, but I know he can overlay these shots. Now, and he can focus. So I would think he could focus really tight, and they'd overlay really tight one right after the other, or he could overlay distance with, just the distance, and he'd get boom, 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 boom. So he could lay it out like that. They're stacked. He calls it stacked overlay. Is the stack always the same distance? I don't think so. I think you can stack them this far away or this far away. If they were stacked this far away, they'd be bip, 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 and you'd have instantaneously close shots. Or they could be far apart. That's just my guess. We're supposed to have a deal go on today. He got wrapped up, I got wrapped up, but he sent me a bunch of shots that, look at that, that's the moon. Now the moon only radiates. I'm sorry, re-radiates. The sun is a radiant source. The Earth also radiates because of the scrub of the atmosphere through space. And I get a lot of people thumbing me down because I talk about space and stuff. Please don't do that here. If you don't believe in that stuff, that's fine, but don't try to destroy my research. I'm showing you things that they're not really that deniable, my friends. You can deny it all you want, but it's I live in a world of reality, what I can see, what I can prove. And this is Mason's image, my image. And this is from that star map. This is no comparison. This is just a few days ago. So, this is exciting stuff to me. Yeah. That's Saturn. Looks like a clamshell. Giants, I don't know what. And all of these things out here, there's some kind of abrupt transition. And this is all, are those particles? I don't know. Are those moons? I mean, I don't know what they are. At this point, I got to work with Mason, see if we can come up with some kind of idea how to move forward, because I don't know how to move forward with this. Other than just to keep looking at them, and I do. I keep looking at them all the time. I can see the dipole, no question. Now this has a dipole here, the black and white, but then it's got a white and then a black here. Normally I would think you'd have the black and the white, but that does not fit the model, but it's there. And this is Saturn. Now is that because it has such a wide field of particles swishing around it? I don't know. Like this, see here? And this is also Saturn. So this had to be a different date and time. And you can see this is the black and the white right there. This is just phenomenal. And that's shooting out just like the Venturi effect we have. The black is bounced back this way. It's almost like the black is smashing into the white, forcing it to go through like the Venturi. And then it bounces back, because that's exactly what does happen. That is exactly what happens. Watch. These are the particles coming down, accelerating like crazy. Bam! They hit the Venturi. You see all the white spray? That's called electron showers. Well, what's happening here is the black is bouncing back. You don't see it because black stuff you can't see. The only way you can see black is if it's on top of the white, obscuring the white. The black does not emit, absorb, or reflect. It's all over the place. I mean, the black is everywhere. But the only time you can see is when it's laying on top of the white. You see it? And that's exactly what my theory predicts, and also they know from Cherenkov radiations is exactly what happens. You get electron showers, which create scads of energy, and you get muon neutrinos, which is just a black. Now they come in, they smash, and it just filters through the water. We come in and we smash, and the black ones go backwards. They come back. And they come back so hard that they make an explosion. That's literally just a gigantic explosion on a subatomic particle level. And it's the only way you can understand it is because of dipole electron flood theory. These are dipoles, they're together, they've seen them, they know this. They call them Dirac Neutrinos, a white and a black. But they just can't, And again, I said, this is Fermilab found these same particles. And we found them pretty close to the same time they did. And I sent this to Fermilab. I said, hey, we got your particles. And I got a, you know, I didn't like the response I got. And I'm blocked from virtually any of these places now because I kept trying to say, please, look at this stuff. I'm not kidding. This is real. And we can do this basically all day long and squirt that into a collector, maybe, and create free energy, possibly. And I was basically assaulted as far as I'm concerned. Called names and everything else. So, I guess that's about all I want to say about that. But I'm going to tell you, Mason is the guy. Now, we don't have any money to do this stuff, and I don't think it takes a lot of money. But the results are just staggering. And they know right now, I've been looking it up about the Newtonian telescopes and all of this special stuff. He does more and more special stuff than anybody else. But they do claim that the Newtonian telescope has unbelievable capabilities and it is cost effective. Look, this looks like it's blowing juice right out of the sides. And all of these are because of this layered stacking. What he can do, I don't know. But I know he's not using any filters. Filters say, forget that stuff. We don't want to see that stuff. I want to see everything. I'll make a decision what I want to see and what I don't want to see. Show me everything. Then we'll decide. And that's what he does. And it's unbelievable. And I got this one today somebody sent me, which as far as I'm concerned, that's a tear in the fabric of the corona, which it's just like a balloon. It wraps around. And the particles try to get out, they try to get out, and all of a sudden when it pops, that's a coronal mass ejection. And you can see down through that, and you see that you got a black hole down in there. And these particles are flaring off at us a bazillion miles an hour. And if they hit our power grid, they can wipe it right out. That's just nothing more than particles coming at us. And we can see into the interior of the sun. All right, the sun charges up like a capacitor. It's scrubbing through space, through the fabric of space, which is saturated, 100% saturated with other particles, and it creates the corona, which is this zone right here. That zone is millions of degrees. You get down onto the surface of the sun, they say it's 10,000. 10,000 degrees, that's all. 10,000 is almost nothing. Out here it's millions, and that's because this is the scrub zone, and you can see all of these fields interacting. You see all of those fields interacting, because these are all particles out here, and these are the kind of things they scrub off with their filters so you never see them. Well, now we can see, and this will keep scrubbing more and more, and it'll keep building, and all of a sudden it'll explode the cosmic micro, you know, the CME. And if it's heading towards Earth, it could be serious. And the same thing happens on Earth, you know. We have the same situation. On the surface of Earth, it's only 100 and something degrees, let's say 100-ish worldwide average. And out at our ionosphere, it's thousands. And in between, it goes to minus 100 and something. This is dipole. Everything's a dipole. This is what we've been finding, is that everything's made of these dipoles. They call them Diracs. This is totally opposite of what's true. This is the energy. There's no matter here. That's just an energy field. For some reason, when it hits other fields, it creates heat and light. This is the actual muon, which is the matter. It weighs the same thing. Every one of them weighs the same thing. This can get big, it can get small. This, same size forever. This is exactly what they say at Fermilab. They were the ones that pointed this out. And I saw this and I said, hey, we found these using light instead of colliding head-on. Huge things cost billions of dollars, and that did not go well at all. But these are those particles, and they do exactly what they say. This one can get bigger or smaller and has no mass that they can determine. I have to agree. This one never changes, but it has this glowy edge around it of whatever the color of light is, and it has a black core, which is just a hard, solid black ball. I agree with that. There it is right there with the color of the light surrounding it. Just a tad. And this one's big. You see it's big? And this one's smaller? The reason is, this one is hitting these particles out here. You see those particles? It's concussing with those fields. Anytime you get field to field, you got energy. Up here, you don't have field to field because it's hiding behind a black one. The black one's just plowing through. All right, so this is particle wave duality. All right, and that's the particle. And as it goes forward, it creates the waves. And now the particle is being pulled out from the wave. And here it explodes. The black can't get through. The venturi has to be tuned correctly so that the black can't get through, but the white can. It just squirts through. And on the other side, the blacks are just waiting for it. These didn't jump over to get to here. That idea of entanglement is not correct. They can, once this guy goes, he's gone. This guy's going to stay, goes backwards. It doesn't matter. They don't find each other. They're not like partners for life. Now, this is the muon neutrino. Never changes, which is what we see here. They don't change size. They don't do anything. The electron neutrino gets a big shower. It's just obviously what we have here. And this, my friends, is subatomic fission. We're dividing the two particles. They're dividing. There's no question they're dividing. Here they were all together, which are supposed to be photons of light, but we ripped them apart by sending the white through and keeping the black back. This is deep stuff.